Today I'm going to be watching a video about Australian geography, and this Australian island is unlike any other on Earth. So yeah, the videos I've been watching about Australian geography, not just an island but the whole of Australia, there's just so many things that are unlike any other place on Earth because of, the size of it, the location on Earth. It's such Australia just in general, is just such a interesting geographical place, and interested to see this one. Don't know what island it is. I know there's a lot of interesting islands. I watched a video about those before, or some of them, but yeah, tell me what you think about this one.
Macquarie Island, a narrow windswept ridge of land in the Southern Ocean claimed by Australia, is a place like no other on Earth.
Even just to see the shape of it is quite interesting, how it's just so vertical and so straight. Just this random island in the middle of the ocean. Cool. I feel like I've heard of Macquarie Island before.
Located about halfway between New Zealand and Antarctica, this UNESCO World Heritage Site is a geologist's dream come true. Rising starkly above the waves, Macquarie Island is the only location where oceanic crust and mantle rocks are actively being thrust above sea level within an active oceanic setting. While other areas expose fragments of the ocean floor, Macquarie Island reveals a deeper, more mysterious layer, rocks from the Earth's mantle itself, which typically lie 30 to 100 kilometers beneath the ocean floor. These rocks have been uplifted to the surface by complex tectonic forces that continue to shape the region today. Unlike most islands, which are formed by volcanic eruptions or built from continental rocks, Macquarie Island is made entirely of oceanic crust and upper mantle materials. This setting allows for direct study of oceanic crust and even deeper mantle materials.
Yeah, that's when he says like a geologist's dream, that really is like, again, tell me maybe someone watching this is a geologist or has like an interest in it. How good would it be to go there and study the land, the rocks and that sort of thing?
Providing a rare and unaltered view into the composition and processes occurring deep within the Earth. By exposing rocks from tens of kilometers beneath the surface, Macquarie Island offers valuable insights into mantle dynamics, tectonic forces, and the way new crust forms and evolves, revealing geological processes typically hidden beneath kilometers of ocean. Macquarie Island sits atop the Macquarie Ridge, an oceanic to oceanic transform fault, where the Pacific Plate and Indo-Australian Plate, both composed of oceanic crust, meet. Here, the plates don't just slide past one another, they also compress together due to the oblique angle of their convergence, with the Pacific Plate moving westward and the Indo-Australian Plate moving northward. This combination of right lateral strike-slip motion and compressional forces creates what geologists call a transpressional transform fault. This tectonic regime results in significant uplift of oceanic crust and mantle rocks, raising them above sea level to form Macquarie Island. Macquarie Island is the only place where these rocks are exposed directly within an active oceanic plate boundary. To understand Macquarie Island's formation, we must go back tens of millions of years, to a time when the Pacific and Indo-Australian plates were part of a much larger tectonic story. The island's origins can be traced to the late Cretaceous through to the early Cenozoic, a period when the region was undergoing significant changes. Around 83 to 55 million years ago, Zealandia, a mostly submerged continent now lying east of Australia, began to rift away from Australia, resulting in the formation of the Tasman Sea. I've made a video on the formation of the Tasman Sea, and you can find a link to that in the description below. Seafloor spreading at mid-ocean ridges,
I actually never knew there was like some sort of continent that was submerged here actually. Tell me if you know more about that as well. Yeah, again, like, when you think, obviously it's like millions and millions of years ago, but what you could find on there, like, that would give some insight into what happened in the past, things like that, like, really intrigue me. Love to know more about that as well. Not something I know anything about, so yeah, if there's any good sources or videos for that, please recommend.
You can find a link to that in the description below. Seafloor.
Well, that is, I guess he's just saying there's a video for his, maybe I'll check out the one from his channel as well.
Spreading at mid-ocean ridges drove the formation of new oceanic crust, which contributed to the growth of tectonic plates including the Pacific Plate. This process occurs at mid-ocean ridges, where tectonic plates are pulled apart by forces from the underlying mantle. As the plates diverge, magma rises from the mantle to fill the gap, then cools and solidifies when it contacts the cold ocean water, forming new crustal layers. Over time, this magma crystallizes into basalt at the surface and gabbro deeper down, creating a layered structure that composes the oceanic crust. The cycle of magma rising, cooling, and solidifying continuously adds new material to the spreading plates, driving them apart and building up the ocean floor. The crust that now forms Macquarie Island developed during this period of extension, similar to the crust that formed during the opening of the Tasman Sea. However, Macquarie Island itself was only thrust above sea level millions of years later due to powerful tectonic forces at the boundary between the Pacific and Indo-Australian plates, when seafloor spreading gave way to a transformed boundary dominated strike-slip motion and compression. South of New Zealand, the tectonic boundary transitions from a typical subduction zone at the Pusiga Trench to an oceanic to oceanic transform fault along the Macquarie Ridge. This transpressional regime causes crustal deformation and uplift, pushing oceanic crust and mantle rocks above sea level along the ridge, creating features like Macquarie Island. In this unique tectonic setting, the plates are not only grinding past one another, but also squeezing together, causing upward thrusting of the rocks from the Earth's interior. As a result of its complex tectonics, Macquarie Island provides a rare and valuable glimpse into the layers that lie beneath the Earth's crust. Walking across the island's surface, one can observe rocks that formed from the mantle, typically buried tens of kilometers deep. The island's geology can be imagined as a cross-section of the oceanic crust, with layers ranging from the upper mantle to the volcanic rocks that once made up the seafloor. The lowest layers are composed of peridotite, a mantle rock that has undergone a process called serpentinization. When seawater interacts with peridotite, it transforms the minerals into a greenish rock called serpentine, a common feature in the oceanic mantle. You may recognise this term as it's associated with asbestos deposits. Indeed, some serpentinized rocks contain chrysotile, a fibrous serpentine mineral classified as asbestos. On Macquarie Island, chrysotile may be present within these serpentinite formations due to the island's unique geology, though the remote setting and limited human interaction mean the natural asbestos poses little risk. Moving upward, you'll find layers of gabbro, a coarse-grained igneous rock that cooled slowly from magma deep within the crust, forming distinctive mineral bands. Above this layer, pillar basalts tell the story of ancient seafloor eruptions. These lavas, which formed when molten rock erupted onto the ocean floor and cooled rapidly, still retain their characteristic bulbous shapes.
It's like so amazing. It's like when we talk about Earth, about exploring the Earth and that sort of thing, like you feel like everything's already done on the land. See people talking about exploring space. We don't have the technology to really do that to any great extent. But when we look at like under the ground or underwater, I mean, you say like how much of the ocean is unexplored, like 95% or something, or we don't know what's there or something like that, one of those crazy facts. But when you see something like this, it's pretty much a treasure chest for learning about the Earth. This just one small slither is like so unique in the whole world, and yeah, we can really like learn so much about the Earth. Like for me, who doesn't have any knowledge of geology or like these terms and that sort of thing, it's like just what we can actually learn about the Earth is quite amazing. And there's a few videos I've watched about Australian geography where Australia's the only place you can really learn certain things about the Earth and about the history of the Earth that you can't find anywhere else. Quite amazing. Tell me what you think about this one as well.
What makes Macquarie Island even more intriguing are the dolerite dikes that crisscross these older rocks. These dikes formed as magma rose through fractures in the crust, creating dark veins of rock that cut across the surrounding basaltic formations. The dikes can be found throughout the island, hinting at the complex magmatic activity that took place beneath the seafloor. Today, the Macquarie Ridge complex is a dynamic zone of seismic activity. Frequent earthquakes, sometimes reaching magnitudes of 8 or higher, are evidence of the powerful tectonic forces at work. Geophysical studies show patterns of seismicity consistent with right lateral strike-slip faulting, punctuated by compressional features such as uplifted blocks and faulted rock layers. Macquarie Island isn't just an isolated landmass, it's a natural archive of tectonic history, offering a snapshot of processes that shape the Earth's crust. Studying the island provides critical insights into the nature of transform and transpressional boundaries. Most oceanic crust lies kilometers beneath the waves, hidden from view, but on Macquarie Island you can touch and examine rocks from the mantle itself. The island serves as a window into the tectonic forces that continue to build mountains, trigger earthquakes, and shape continents. Beyond geology, Macquarie Island is an ecological treasure. Its rugged landscape, formed by tectonic upheaval, is home to unique wildlife, including penguins, seals, and seabirds. The island's marine surroundings teem with life, sustained by nutrient-rich waters that are stirred up by the ocean's interaction with the ridge. These ecosystems are intertwined with the island's geological story, creating a natural laboratory where geologists and ecologists alike can study the interplay of life and land.
That's what I'm going to say. Like, this sort of place, is it like anywhere for tourists to just go there for holiday, or is it purely for science or scientists? Like, I would imagine you say like a natural laboratory, but I guess they probably have a lot of like scientific laboratories and have a lot of people from a lot of different countries going to visit to study the island. Is that the case? Tell me more about that. What's the population and that sort of thing? An amazing
In
place.
summary, Macquarie Island is a place of raw and rugged beauty, born from the collision, compression, and lateral motion of the Earth's tectonic plates. It represents a rare geological environment where mantle rocks have been thrust to the surface, exposed to the air for the first time in their existence. In the grinding and lateral movement of the Pacific Plate against the Indo-Australian Plate, we see the forces that have shaped continents and oceans, thrust mountains skyward, and created deep oceanic trenches. Walking along the cliffs of Macquarie Island, you're standing on rocks that were once deep beneath the ocean floor, now part of an island continuously moulded by Earth's relentless energy. In this desolate place, we find not just an isolated island, but an example of the dynamic forces that have shaped our planet over eons. Macquarie Island remains a site of fascination and wonder, a rare and unique glimpse into the hidden depths of Earth, and a reminder of the incredible power that lies beneath our feet as massive slabs of tectonic plates grind together, driven by the relentless forces of Earth's mantle. Hope you found this topic to be as interesting as I did. Consider liking the video and subscribing if you'd like to see more content just like this. And as always, thanks for watching.
Yeah, I'll leave a link to that in the description, so go subscribe to the channel. Yeah, amazing. Like, stuff like that just makes me like happy when you see these amazing things like created by the Earth itself, this whole island. The only exposed part of the mantle, like, oof. I never knew that existed, so yeah, I really learned a lot today from that video. Tell me if you know about that. I'm sure maybe Australians know of Macquarie Island. Do you know the history of it like this and its importance? Is that the sort of thing you learn about in school, like when you're learning about geography? Is that one of the sort of things you would learn first? Because it is in Australia and so important to the world. Tell me what you think about this one. Thanks.